Hi everyone, welcome back to yet another video yet another day of talking about the Bohr model of an atom. And I promise this is going to be the second last video on this topic because I need one more video for the questions and then we will be good to go to the quantum mechanical model, which is the next big thing. Okay, alright, so this is the Bohr model of an atom, which we have already discussed. There is going to be a nucleus in between and there are going to be shells or orbits on which electrons are going to revolve around the nucleus. Okay, and these shells or these orbits are going to be having certain energy, and this energy is not going to change for anyone. Well, I just need to redraw this. Well, there are just two shells. Okay, let's talk about the two shells here. Okay, so now this is the nucleus and the electrons are going to be present in these orbits, and these orbits are this is n is equal to 1, which means this is the first shell, so the n value for this is equal to 1. Well, this is the second shell and the n value is equal to 2, and that is how your values for n is going to increase. What I haven't said up till now is that n is also called the principal quantum number. Okay, so here the n is equal to 1, or the principal quantum number is equal to 1. Here the principal quantum number is equal to 2, or the n is equal to 2. Alright, so well, I will talk about these quantum numbers once we land into the quantum mechanical model, but for now I'm just telling you out of context because we know we will be using these principal quantum numbers in a while, so I think you should know. Okay, so now the electrons are present in these orbits, and these electrons are going to be revolving in these orbits with certain defined energy, and that energy is not going to change for anyone in this world. Okay, unless we provide this electron with certain amount of energy. If we from our side allow this electron to have some energy or gain some energy, then this electron can do stuff. Now, what stuff this electron can do? Okay, this electron can do, like, of course it is not going to dance. Okay, it is not going to jump out of bed of energy. It is going to actually do something called excitation. So whenever something has high energy, electron, if it is having a high energy, it is going to perform something called excitation. Excitation meaning जिस भी level पे वो अभी है, since it is going to be, this electron is at n is equal to 1, right? Excitation means that it is going to go to a higher level. Okay, I'm not saying just next higher level. हो सकता है ये n is equal to 2 पे चला जाए. That is also a possible thing to happen, right? But not only n is equal to 2, it can go to n is equal to 3, n is equal to 4, n is equal to 7, whatever. Okay, depends on the amount of energy we are giving. अगर हम इसको blue light दे रहे हैं, ठीक है, blue light is having a higher energy in comparison to red light, right? So of course it is going to go to a higher level. If we are giving it red light, okay, it might not even excite, or it may excite but at a lower, maybe it will just go one level up. Okay, so this is called excitation. Is it clear? I just want to make this word very clear, excitation, and then we'll move on. Okay, so let's say this electron is getting excited and we provide this electron with certain amount of energy first. So the first thing that we have to do from our side is providing this electron with some energy. Okay, now this electron, after having that amount of energy, is going to gain that energy, and then it is going to go to the next higher level. Or maybe, okay, let's draw one more shell because that is going to be even comfortable. Okay, so this is one more shell, and let's say this electron, after getting the energy that we provided it, is going from n is equal to 1 to n is equal to 3. Okay, now this electron is said to be in the excited state. Okay, now what is the meaning of excited state? The electron, initially it was stable, it was doing its work, it was revolving around the nucleus in its defined path, but we decided to give it certain amount of energy. Now this electron, with this excess energy that it has, is getting excited, and out of excitement it goes to a higher level, okay, which is of course n is equal to 3 now. Now this n is equal to 3 electron is in the excited state. So now just imagine, okay, let's say you have a result coming up, you want to know whether you pass, you failed, God forbid you should not be failed, but you just want to know the answer, whether you're passed, you're failed, you're just nervous, you're excited. Okay, so you want to get out of that state as soon as possible, because you want to know it, either you're passed, failed, what is it, right? So similarly, this electron is in the excited state and it wants to come back to the ground state, or it wants to reattain stability. Okay, everyone in this world wants to be stable. Stability is something which everybody craves in life. Okay, people always keep asking everybody, like, when are you getting settled? Okay, this question is very common because everybody wants to achieve stability. Okay, once you have a good stable job, stable, everything is stable, you want to just settle down, you want to be stable in life, right? So same goes for electron. When it is excited, okay, we give it certain energy, electron become excited, but now it is craving for stability. Okay, now this electron, in search of stability, will now come back to some lower level. Now this electron, initially it was at level 1, okay, and then excitement ke baad it goes to level 3. Now after going to level 3, it might come back to level 2 or level 1, whatever. Okay, it depends on the electron. Okay, so if this electron comes back to level 2, ओके, स्टिल इट हैज़ सर्टेन अमाउंट ऑफ एनर्जी लेफ्ट, बिकॉज ये आया तो 1 से था, तो इसने इतनी सारी एनर्जी गेन करी लेवल 3 पे जाने के लिए, फिर इट कम्स बैक टू लेवल 2 एंड इट हैज़ सर्टेन अमाउंट ऑफ एनर्जी, इतना अमाउंट ऑफ एनर्जी स्टिल लेफ्ट. ओके, दैट एनर्जी, अब वो इलेक्ट्रॉन, ऑफकोर्स एनर्जी हैज़ टू बी कंजर्व्ड, राइट, जितना एनर्जी दिया था उतना भी बाहर आना चाहिए. ओके, सो इतना एनर्जी लेके इलेक्ट्रॉन गोज टू लेवल 2 एंड द एक्सेस एनर्जी इज गोइंग टू बी कमिंग आउट in form of light. Okay, and that light is what we see on the screen, okay, emitted out of the electron which was initially excited by us only. Okay, and that is called the emission spectra, or that is called the emission line. ठीक है, so इसलिए when you see when you see white light, when it is passed through a prism like this. Of course, I think everybody knows white is not exactly a color. Okay, white is just an amalgamation of all the different colors, and if we split it, we're going to see a pattern like this, and this pattern is going to be of different colors which exist in white light. Okay, so all these different colors are present in white color, and when we split it, we see these colors in a continuation manner. We see red, we see orange, we see yellow. All these colors are present, like they're not having any spaces. ऐसा नहीं red के बाद space है, फिर yellow है, फिर space है, फिर orange. It's not like that. They're just in continuation. So this kind of spectra is called a continuation or continuation spectra, which means it is continuous, or a continuous spectra is what it's called. Okay, but okay, if we talk about the spectra of any atom, see, I have been calling it hydrogen atom since a long time, but it is not hydrogen atom, it is any atom for that matter. अगर हम किसी भी atom का spectra देखते हैं, so, और emission spectra देखते हैं, so it is not continuous. Okay, why is it not continuous is this. Okay, this is the spectra of hydrogen atom. So the spectra of hydrogen atom, जैसे कि मैंने बोला, when will it exist? Electrons are going to be there, simply doing their work, revolving. Okay, we are going to provide it energy, राइट. सो हमने क्या किया, वी आर डूइंग नथिंग बट ये जो हाइड्रोजन एटम्स का सैम्पल है, इसको हम पहले एक एनर्जी प्रोवाइड करेंगे. वी हैव टू मेक द इलेक्ट्रॉन्स एक्साइट. ओके, अगर वो एक्साइट ही नहीं होंगे तो वो नीचे आके एमिट कैसे करेंगे एनर्जी, है ना. दे हैव टू एमिट एनर्जी फॉर अस टू सी इट, राइट. सो फर्स्ट वी हैव टू प्रोवाइड दिस सैम्पल ऑफ हाइड्रोजन एटम विद सर्टेन अमाउंट ऑफ एनर्जी, एंड व्हेन आफ्टर एक्साइटेशन we get to see this particular spectra, and this spectra is called the line spectra of hydrogen atom, and this is called the emission spectra. So if you see the definition of an emission spectra anywhere in your NCERTs or any other books which you might follow, you will see that spectra which happens when the electrons have absorbed energy is called emission spectra. So of course electrons were having energy which was absorbed. We gave it it in form of electromagnetic wave, or we heated the sample, whatever. We provided that particular sample with certain amount of energy, and that energy was absorbed. And after being excited, okay, after excitement, the electrons are going to come back to the ground state, because, well, stability, which is something everybody runs for. And after that, the electron is going to emit certain amount of energy out, which we see on the screen, which is called the emission spectrum. Okay, so the exact photographic negative of the emission spectrum is what your absorption spectrum is. And in this video, I hope I just wanted to talk about the emission and absorption spectra in detail. Okay, and of course, as I already said, Bohr actually gave us the values of these energies जो हम बात कर रहे हैं ना, कि n is equal to 1 पे there's going to be certain energy, n is equal to 2 पे also there's going to be certain energy, 3 पे there's going to be certain energy. So actually Bohr was able to give us the formula for these. Okay, and not only that, he was also able to give us the formula for the radius of any atom. Okay, he gave us a general formula, and for hydrogen we can find it out easily, but he gave us a general formula, and that is what I'm going to be writing here. So energy for any level, okay, I'll just use a black pen. So energy for any level, the nth level for that matter, okay, for any level is going to be what? It's going to be minus 2.18 into 10 to the power of minus 18 upon 1 upon n square. Okay, this n is the shell number. Of course, in joules, energy is going to be in joules, right? So if I talk about n is equal to 1, okay, here n is equal to 1. If I put the value as n is equal to 1, it's, and this is only for hydrogen atom, okay? This is only for hydrogen atom, okay? In general, if we talk about any atom, this 1 is going to be z square. It's going to be z square upon n square, and this z is nothing but the atomic number. So if we talk about, let's say, sodium atom, sodium has an atomic number of 11. So in the numerator, we will be having 11 square, okay? This is the general formula. But for hydrogen atom, energy of nth of hydrogen atom, in hydrogen atomic number is 1, so z को हमने हटा दिया. It's minus 2.18 into 10 to the power of minus 18 1 square, which is 1 upon n square, okay, joules. So if I talk about the first level, which is the n is equal to 1 level, this is 1 square upon 1 square, and this is the amount of energy for the electron in the first shell, okay? If we talk about an electron of, in hydrogen atom in the second shell, it is going to be minus 2.18 into 10 to the power minus 18 1 square, since hydrogen atom, upon 2 square, okay, joules. Is this clear? Okay. Of course, if we talk about the difference in energy, it will be delta E, which is E2 minus E1, and which is what we can easily calculate, okay? And this is the formula for energy which hydrogen atom, or any atom for that matter, which Bohr actually gave us. Is it clear? All right. So in my previous videos, I've already discussed about this negative sign. People might be wondering energy negative क्यों है? Because there is an electrostatic force of interaction between the nucleus and the electron. Okay, this is an attractive force. So attractive energies are always negative. That's why there's a negative sign here. And energy at infinity is equal to 0. ठीक है? तो infinity से पहले जितनी भी होंगी वो सब negative में ही होंगी. And the reason for it is this attractive force. Clear? And the second formula which actually he gave us was, okay, I'll be talking about these lines in the next video. Okay, so this radius of any atom is 52.9 into a square. Okay, what is this a square? This a is the well, for your Bohr or your hydrogen atom, this a is equal to 1, but of course it will change with respect to any atom that we're talking about. Clear? So this is 52 and this is in picometer, and I hope you know how small is picometer. It is 10 to power minus 12 meter, so you can imagine how small that is. Okay, so depending upon the n level that we're talking about, this a value will change. It's with n is equal to 1, it is going to be 1 square. If it is 2, it is going to be 2 square, and so on and so forth. Okay, so well, I hope you understood the concept of this video. This video was basically to talk about the emission and the absorption spectra and what is the meaning of these two spectras. And if you did understand, then do press the like button. If I'm too fast, then please comment down below. If you think that I'm speaking too fast, you can actually there's a feature in YouTube where you can actually slow down the video and watch it. But I'll also try to slow down in my next videos if you think I'm really fast. So thank you so much for watching, and if you really like it, then do press the like button, share with your friends, and well, stay tuned for more.